Hey, I'll have a short video follow-up to our last one on multiplying polynomials. And this is about binomial expansion, so it's a different way to approach certain problems that do ask that you're multiplying something by itself. Specifically, if we have a binomial, so a two-term expression, and we are raising that to a certain power, there's two different ways actually that you can solve this problem. One is by multiplying, which I will show quickly. Now again, if you're multiplying something by itself, that means you're taking it, in this case 3 times, and multiplying the first times the second parentheses, getting a result, and then taking that and multiplying it by the last parentheses. So for example, I could use the box method to multiply 2x times 2x minus y times itself, get 4x squared, negative 2xy, negative 2xy again, and positive y squared, because a negative times a negative cancels out. That'll give me something that when I unpack my box, I'll see that I can combine some like terms here and end up with 4x squared minus 4xy plus y squared, which I will then have to multiply to get my final answer. Multiply that again by 2x minus y. Okay. And then basically do the box method one more time to get my result. So in this case, three columns, 4x squared, negative 4xy, positive y squared, and then 2x minus y again. That's something we're multiplying with. 2 times 4, 8, x cubed. Don't forget that's an invisible 1 as your exponent. And then negative 8x squared, y, 2xy squared. Multiplying down here, we have negative 4x squared y. Negative times negative will be positive 4x y squared. And lastly, negative times positive, negative y cubed. And when you simplify that, you'll combine like terms one more time. Your final answer actually will be 8x cubed. These will combine to give minus 12x squared y. These will combine to give positive 6xy squared. And then lastly, you have a minus y cubed. So that's one way to approach the problem, multiplying it out twice. Another way that you can approach this problem is what's called binomial expansion. And the larger the exponent, the more useful this will be. So it is something that I recommend that you take into account, depending on what problem you're given. So let's use the binomial expansion method, or take a look at what that is. And the first thing that we're going to be required to do is learn about Pascal's triangle, which is a useful tool in order to help us expand our binomial accordingly. Pascal's triangle starts with a trio of ones, and then each row below that is going to have one extra term. So we have 1, a 1, and a 1. That's 2 things there. In this next row, we'll have 3 things, 1, 2, and 1. The next row will have 4 things, 1, 3, 3, 1. And the pattern is ones will always be on the outside of Pascal's triangle, and the numbers in the middle come from adding the numbers above, like 1 plus 1 is 2, or 1 plus 2 is 3, and 2 plus 1 is 3. So the next row down, we would have ones on the outside, add our numbers in the middle. 1 plus 3 is 4, 3 plus 3, 6, 3 plus 1, 4, and so on and so forth. We can keep going. As many rows as we wanted to. The pattern is always the same. 5, 10, 10, 5, 1. Okay? And what we're going to want to do is to take the row that has 1 more than our exponent. So in this case, we're going to choose the row that has the 3 in it. You'll see that the 3 shows up. That's our exponent here as well. This row has 4 terms in it. We're going to use that row. We'll see why shortly. But basically, the row that has a 3 is the row that we're going to use. So we're going to use the row 1, 3, 3, 1. and set up 3 different columns. Okay? That's going to be called Pascal's triangle row, or what's also called the coefficient row. Then in our next row down, we're going to look at our first term, which is, in this case, 2x. And we're going to do a bit of a countdown. So we're going to take 2x to the 3 power of 3. 2x squared, 2x to the first, and 2x to the 0. So that's why we have 4 columns. We always want to end our countdown at the power of 0. Okay. We're going to simplify that shortly, but we're also going to do the same thing with our second term, which is negative y. We're going to take negative y and also do a countdown. But in this case, we're going to do that countdown in reverse. So 3, 2, 1, 0. What's going to happen is that when we multiply these 3 simplified rows in each column, we're going to get the same answer that we did when we multiplied the problem out in red earlier. So, for example, I have 2x cubed. 2 cubed is 8, right? 2 times 2 times 2 again is 8. X cubed stays the same. 2x squared is 2 times 2, which is 4. X squared. Anything to the first power stays the same, and anything to the 0 power is 1. So all I've done is simplify this row below. And I'm going to do the same thing now with our bottom row. Okay? Anything to the 0 power is 1. Anything to the first power stays the same. A negative times a negative will become positive y squared, times another negative y will be negative y cubed. And if at the end of my problem I multiply each column out, let's see what happens. 1 times anything stays the same. Anything times 1, again, stays the same. Multiply your next column now. 3 times 4 is 12. X squared times negative y is x squared. Y, negative sign goes in front. Notice that all of these numbers in our next column are positive, so we're going to be adding. This will be positive. 3 times 2 is 6. X times y squared is x, y squared. And lastly, 1 times anything will stay the same. This answer that we have down here matches what we found earlier. 8x cubed, negative 12x squared y, 6xy squared, and negative y cubed. They all match. And the important part about this, again, as I mentioned, as you get to larger expressions or larger problems where you'd have to simplify binomials. And let's take a quick example here. If I was asking you to multiply this out by itself 5 different times, I don't even know that I have enough parentheses to fit that, but what that would require is that you use the box method 4 different times. And that's not exactly easy. Okay. We saw maybe towards the end of our simplifying in red that it required a lot of combining of like terms, especially with variables that are not the easiest to work with. Whereas, okay, you have to do the box method 4 times here. Whereas, all we would need to do, and again, our exponent is 5, we would have to look at the row in Pascal's triangle that has a 5 and set up, in this case, 6 different columns for us to multiply out the same way. In this case, we would have negative 5x in a bunch of different parentheses with a countdown, a positive 2y in some more parentheses, again with the countdown in reverse. We would simplify our first and second term rows as we did here. All of these simplified to allow us to multiply out our columns to give our final answer. And that is why binomial expansion can be so useful. So if you ever encounter a problem that involves taking binomial to a certain power, 3, 4, 5, you might want to think about using Pascal's triangle and binomial expansion to approach the problem instead of multiplying. So I hope that piques your interest in math a little bit. It just shows, again, a lot of these problems that we're encountering in Algebra 2 can be solved in a variety of different ways. And yeah, I hope that helps you while practicing.